will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. When I look at my
Don't be embarrassed. Don't hide. You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too long, wake up, my love. Please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love. Please don't give up on me.
What is up? What is up, you guys? We are back at it again at 100 days of Rootkit. All right, 100 days. 100. Today officially marks day 48. 48. We're about to hit that halfway point. I think on Sunday. Nice chill Q&A day on Sunday, halfway point. Good day to land on for the 50th, alright? 50th day in this journey. Hopefully you guys didn't develop too much cancer since yesterday, alright? I know we were really infecting you guys with some radioactivity, alright? Just really mutating your cells, but hey, we're gonna get through it, don't worry. We're gonna get through it. So let's go ahead and finish up our little intros here. If you guys aren't aware, we are Rootkit, a non-profit based here in the US of A's. Alright, in the US of A's. We like to do a lot of things for, what do you call it? For free. Alright, we're doing this class. Alright, 100 days straight in a row. Our little boot camp equivalent, some would call it. Holy crap, that is really loud. Let me go and turn that down. There we go. 100 days. Sorry, I'm getting like all sorts of distracted. 100 days we're doing this. Our cert is better than any comp sci degree. Don't go to college. Don't waste $100,000 in 4 years of your life. Look, money you can make, you can lose, it's whatever. It's not a big deal. Time though, 4 years. You can't get that back. You gotta find out amount of years. All right. Once it's spent, it's spent. There's no way you can make that back. All right. Don't waste your time with college. All right. Come do 100 days of Rootkit. Get certified, and we'll help you get a job. All right. Don't go to any other boot camp. They are all scams. They're gonna charge you up to $20,000 and promise you the world and not deliver. For you guys that have been with us so far, look, you know how much we've taught so far. You go to any of those other boot camps, you can go to their sites and see what they'll teach you. It's maybe a quarter, and that's being generous, all right, of what we're going to teach you, because our shit's actually useful. Theirs, useless, all right? On top of all this free stuff we're doing, we got our giveaways going on our blogs. So we got our week 7 giveaways now live, all right? We're going to be doing a mystery items, one of our merch items. What it is, I don't know. We're going to flip on Sunday, all right? Sunday, we're going to flip and see all together. We're going to figure out what we're giving away. On top of all that, if you like what we're doing and you want to help support us, we have our charity stream donation link thing. It's going to be in the description of both the Twitch and the YouTube streams, all right? Head over there. If you like what we're doing, spare $1 or $2, all right? Depending on how much you donate, we have giveaways, like our you'll get our stickers, our Epic collab t-shirt, and this awesome Rootkit sweater. Look at this thing, all right? Look, even got the logo on the back. It's super, super hype. Absolutely love it. Additionally, all donations are being matched 1-for-1 for the first 10,000 donations. So it's like you're doubling your money. You're being extra contributable. We have pillars here along the way, like streaming for 24 hours straight, shaving my head here live on stream, and shaving my beard. Yeah, no, that's one we don't need to go. All right, we don't need to do that one. We're just going to move on. We don't need to talk about that one. That one's no bueno. No one wants to see me without my beard. I will lose all my magical powers, alright? No one wants to see that. Alrighty. So before moving forward, I see decisions is hyped up. Before moving forward, any questions, comments, concerns? If you're going to put concerns about your own mental health and the cancer that you're receiving from this, look, hey, good luck. That's on you, alright? Can't help you with that, alright? I'm already chock full of cancer myself. Every day I program, I shorten my my lifespan. Just all the cancer that I get. All right. You know what we're gonna get back into. Oh yeah, we're not done with it. We're gonna continue our journey with classes, with objects, all right, with blueprints, with all that funness. I'm gonna make a new Well, I'm gonna delete this stuff. There we go. All right, we're gonna continue on from where we left off yesterday. All right, with our little NPC thing. So I gave you guys a challenge yesterday, and I hope you guys did it, accomplish it. I saw none of y'all turned it in. All right, none of you guys posted in the 100 Days of Rootkit chat. So I'm a little concerned. All right, I'm a little concerned, especially if you're confused about it right now and you weren't practicing, trying to attempt the challenge. I'm a little concerned for you because I don't know if you're going to be able to keep up as we move forward here, all right, on these next couple of days. So make sure you're practicing out of these days, all right, outside of these lessons we're doing. It's required, all right, unless you're just some fucking wizard, all right, you can't just understand it in 2 hours, all right, you got to also be able to perform it. Learning is one thing, performing is a different thing, all right, you got to be able to perform it also. And we're going to be doing a lot more over the next 50 days, more performance, more challenges, more like do-it-yourself stuff, getting your hands on, because we're past the written stuff, all right? The written stuff was like the first 30, 40 days. We're on to the programming stuff, so you got to perform on these ones. All right, just looking, making sure, one last pass for any questions. So let's chug along here, shall we? So we said yesterday for the challenge to make it so we can spawn 2 NPCs and have those NPCs fight each other, all right? This is an NPC. NPCs could be chickens, all right? Let's get some chicken battling going on here. Is that what's called? Rooster cockfights? There we go, cockfights. Let's get some cockfights going on here, all right? I know it's illegal, but guess what? We're programming. We own this world. We can do whatever we want, legal or not. All right, so we're gonna do some, what's the word for it? Unethical cockfighting today. All right, so get ready for this. So for our NPCs, we have an attack, all right? But we want also a way to process taking damage and factor in our defenses, right? Factor in our defenses. So for every one of our NPCs, they can perform an attack, but they should be able to also receive some damage, all right? Take some damage, all right? So let's make a new method in here called, I don't know, take damage. And remember, it's a method, so we gotta put that self thing in there, all right? We gotta put that self thing in there. It's a but at the end, so we'll add the little but, the little colon, all right? So when we take damage, we need to know how much damage we're going to take, right? So in our function here, we should ask for how much damage they're trying to inflict on us, all right? So let's say damage. This is how much damage they want to inflict on us. Now we can do some simple logic here or make some super fancy algorithm for calculating defenses, resistances, blah, 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 blah. Totally up to you, right? Totally up to you. We're going to start off with something very simple, right? What is that? Well, we're going to say self.current HP, all right? What our current HP is going to be minus equal, this is the shorthand, remember, this is the shorthand for equals self.current minus, and let's say damage. All right, let's say damage. So this is the long format. I'm gonna go and comment this out, and then show you guys self.current HP equals minus equals damage. All right, shorthand version, because I want us to start using this shorthand version more and more as we move forward. So I'm going to still show the longhand a couple more times moving forward, but I'm gradually going to just do the shorthand. All right, so we're getting you guys accustomed to the shorthand. So we're going to subtract the damage directly against the health. So if I do 7 damage, if my attack is 7 damage, I'm going to, when I take damage, I'm going to just take the whole 7 damage. We're not factoring in any type of resistances, which we have something here called base defense level, which we could potentially factor that in. All right, I'm gonna remove this one right here for now. So we need 2 chickens. All right, so we're gonna say chicken. What's this chicken gonna be? What's a cool like name for a chicken at a cockfight? Ideas. You guys can put some ideas in the chat. I'm trying to think of something creative. Razor. All right, let's do razor. Razor. All right. Now razor is just an empty variable. We got to use this blueprint, this class that we made, and construct a new object from it. All right. How do we do that? We say NPC and then that. All right. We're not going to give it any custom. We're not going to customize the total HP. We're just going to let it be the default. All right. And then now we need another chicken. So let's say chicken, and I guess I should use the right format here. There we go. Chicken. We need another name. Any ideas for our next name here? Oh, also before moving forward, I am in the Discord, like always, in the events chat. So if any of you guys are Patreon or Discord members, you can go and drop in there and speak away, interject whenever you would like. All right, so we got Razor, and I'm gonna call this one Club. All right, NPC. So we got our 2 little chicken here. All right, and we're doing role-based attacks. So one person will attack, and then the next person will attack. So how do we go about doing this? Well, we know they both have built-in actions called attack. It's in our blueprint here. So if we say something like chicken.razor, chicken razor dot, and then we can see attack shows up here now. If we click on that, that's our method. So we can put parentheses around it, and bam, he's now performing an attack. It's going to return to us some type of integer value, some type of whole number. All right, now it's on to us what we want to do with that number. All right, what do we want to do with that number? So we want this number, this attack that we're getting, to damage Chicken Club over here. Chicken Little. Well, you should have said that a little earlier, all right? A little late now. So we have this other thing called take damage. Take damage, when we're attacking Chicken Club, needs some type of damage inside of it. All right, we need to put the damage we want it to receive in here. So what we can do is take chicken razor dot attack here, copy the whole thing, all right, and move it inside of take damage, because chicken razor dot attack here is going to generate a number, return it. All right, it's going to return it, report it back to us, and then we can use that number inside of our take damage action, our take damage method, to actually reduce the health of our Chicken Club. All right. So if we print the chicken razor dot health current HP, and then after that we print the Chicken Club dot current HP, we'll be able to see both of their HPs, and Club over here should have less HP than Razor. So we can test this out and see. So if we open up our terminal here, and remember, no, we're at the top level directory. So we can just go ahead and click on our little play button. And we can see that one has 100 health. So Chicken Razor has 100 health. He's very, very healthy right now. And Chicken Club, he ain't looking too well. All right, he lost a couple feathers on that attack. He's sitting at a little healthy 85. All right. So we've successfully started doing a whole fight. Just looking at the comments here. We successfully started doing a whole fight. All right, so we have the ability for them to fight each other now. All right, for them to fight each other. Now, you may ask, why don't you just do chicken club dot current health minus equals chicken raiser attack. Great question. You can do that. You can 100% do that. That is a way of doing damage to its health. This may not be the ideal way for you because this isn't factoring things like defense or stamina or whatever you want to do for your resistances. This is a very just simplistic way of subtracting the health against their current HP. Yes, we are doing the same thing right here, but if we ever wanted to change that, this will not reflect it. Alright? So if we wanted to ever do anything with maybe like Bates' defense here, so let's say their damage is divided by base defense. Alright? Why are you? Oh, self.base defense. Self.base defense. Now it's a little bit more complicated. We have our defenses in here. This is not including the defenses. We could add more logic here and add more logic, but now this kind of is still ruining it all, because what if we want club here to attack razor? We would have to then copy all of this logic all over again and have it execute and that will make our code not dry anymore. We're going to be repeating ourselves. So if we have it all here in one place, all we have to do, the most we would be repeating, is us saying the take damage method. Alright? We wouldn't be repeating the logic. So if we go ahead and do this, we'll see we'll get a slightly different answer this time. 97.0. So his resistances are affecting pretty well right now. Alright, affecting a lot. From 85 to 97. This chicken, he's got some diamond armor on right now. Kawaii said, I missed the beginning. We're fighting chickens? Yeah, we're doing cockfighting here live on stream. Alright, hopefully Twitch won't take this down. This is some pretty hardcore stuff if you ask me. Alrighty. So any questions in regards to that? Again, all we did was make another method and we called it take damage. It requires one thing to be passed to it, which is the damage. And then inside here, we can perform any logic we want. You know, bring in defense stats or whatever we want to do. And then we're going to subtract our current health from what we've calculated out. And to utilize this later on, all we need to do is have one chicken perform an attack, and then have the other chicken then do something with the attack, aka do the take damage from it. No tricks at all. Alright, any questions from that before we chug on forward here? Alright. Then let us continue. Alright, then let us continue. Let's see how we want to continue today. I guess we're gonna go over importing, alright, because our code's getting, it's not really long, but it's kind of confusing a little bit. What I mean by confusing, well, we have a class here, which is our blueprint, and like right below it, we have our actual game being played out, and you know, we're commingling blueprints with gameplay, and it gets very, very confusing very, very fast. It would be nicer if we could organize things. So we could have like one file that's just meant for gameplay, another file that's meant for us making all our blueprints, and maybe like more files for other organizational things. That would be very, very convenient. And luckily we can do that. All right, we can do that. We've been kind of doing it with our import statements, but now we're going to show how you can do it with your own custom import statements and your own custom files. All right, so let's make let's continue with our little game here. So let's go ahead and make a new folder, and then we'll call this folder, I don't know, epic game. All right, it's going to be our epic game in there. And let's go ahead and make a new file in our Epic game. Let's see here. Question might sound dumb, but the way the attack and damage lines are written, does that mean that any NPC or player could use those same lines in battle, rather than the lines being NPC/player specific? Great question. Great question. This is going to be attached to any object you make that is based off of the NPC blueprints. All right. So if I wanted to make player 1 here, and if I based our player 1 off the NPC, he will now have the abilities of all the things in our blueprint. So if we say player 1 dot, you'll see our player 1 gets attack, base defense, height, HP, take damage. He gets everything in the blueprint. So this is a way we can pretty much automatically, I mean, that's the most powerful thing of our classes here, is they're blueprints that we can use to mass manufacture a bunch of objects, like a bunch of players, shopkeepers, chickens that we want to kill, goblins. They can all use this, because at the end of the day, if we were making a game, they should all have these stats to a certain extent, right? So it's an easy way to write a little bit of code so you can be lazy, all right? We want to be lazy in programming. The less lines of code we can write and the more power we can give ourselves with less lines of code means we're just ideal peak laziness, all right? So we write a little code so we can do less work later. That's the big important thing, all right? Goal, laziness. We should make some merch here at Rootkit, just like some posters or something that people can get. Just dream goal, lazy. Get paid to be lazy, all right? I think that'd be a hot fire. Let's see here. Is it really that simple how attack damage works in games? Yes. It's literally this simple. This is it. This is every game in existence is literally right here in front of you. Now, don't get me wrong, those games are going to, like I said, incorporate more things like your base defense, stats, etc., but have you ever looked at a stat screen? I don't know, what games do you guys play? Let's see here. Player stats screen in Elder Rings. Elder Ring. You want to make an Elder Ring clone, all right? Let's see what we got here for pictures. Will this one work? I never played Elden Ring, so forgive me. Yeah, you see this stuff here? These are your variables. You're very familiar with this if you play games. You've seen these variables before. You've messed with them. You've leveled them up. You've added them up before. You've directly seen how they affect how you play the game. There's no special anything. It's literally like if I have 74 attack power, then I have a variable here literally called self.attack power, and it's going to be equal to 74. All right, there's no magic. It's literally exactly what you're familiar with. It's now on you on figuring out, okay, I got 74 attack power. I hit something. When you hit something, you are performing an attack move, which will calculate how much damage you're supposed to do, but the NPC that's receiving that damage has defenses. So it needs to calculate, based off the damage you're about to do, what are its defenses going to negate, all right? So that's where things like, is there defenses in here, right? There should be somewhere, right? Maybe not. I don't know. Like I said, I don't play this, but you get the point, right? Yes, goal equals laziness. Exactly. 100%. And conveniently, the more lazy you are, the better your code is. It's funny how they kind of coincide. The smarter you are with developing, so you're allowing yourself to become more lazy, you're actually making better, more efficient code. Hey, look, I told you guys from the beginning, this is the dream job for any lazy person, all right? You come here. Programming is easy, all right? If you want to be lazy, you become a programmer. All right, let's see. Okay, for the next game, can we make it like a 21 questions type of game or something? like Magic 8 Ball. We'll see. This all makes me really curious on how the code for Phasmo is written with all the different ghosts affecting sanity. It's the same type of logic. It's nothing super fancy. It's the algorithm that you want to develop. What is an algorithm? Well, you've already made algorithms. All this is an algorithm. Me doing my health minus damage is an algorithm, all right? You making it more complex by factoring in defenses or sanity or whatever it is, that's you just making it a more complicated algorithm, all right? What do balance teams do? Well, they'll come in here and be like, oh, this defense is a little OP right now, all right? So maybe we shouldn't just directly divide against the damage. So they'll use some math to figure out what else they should be doing here in order to, you know, readjust everything, all right? Sometimes if the algorithms and the calculations they're doing are set up properly, it will be something as easy as adjusting. For example, I think our attack is better suited for this right now. It's easier to fine tune. Let's say our attack, which right now our attack is our base power level plus our current HP times 0.1. What does that mean? It's going to give us 10% bonus based off our HP. So this attack scales based off HP. Let's say that was a little too overpowered. 10% of your base HP is a little too much. All right, so we want to change this instead to, I don't know, 0.07. Now it's going to be 7% of your. We just did balancing. You are now, write that on your resume. You have balanced team experience. All right, it's literally just that easy. Now, getting the balance right is difficult, but changing the balance is very, very easy. Really good idea. Yeah, that would seem like an interesting game to try and make. Hopefully by the end, we should be able to code a game like Phasmo's, fingers crossed. You could, 100%. We're not going to dive into game engines like Unity or Unreal Engine, which you guys can, that's where most games are made, and both of those, they're free to use. It's literally what all the experts use. You're not getting like cut out of anything special when you download those. But the way you go in programming those games is exactly the same of what we're doing right now. There's literally no difference. The only difference is that this will be associated to some visual aspect, all right? But the code itself is exactly the same. It's exactly the same. Let's see here. Stardew, Pokemon. Yep, exactly. All right. Yeah, you guys are very familiar with this stuff. It's, like I said, it's confusing at first, but the more you mess with it and the more we can relate it to real world things, hopefully it will start to make more and more sense for you guys. So let's get back here into organizing our code a little bit, all right? So we want to make an epic game, all right? We want to make an epic game. So before we make our epic game, let's go ahead and make this a Git repo, all right? Should we? All right, we're not going to do the Git repo just right now because we'll revisit that probably on Monday and start redoing our Git stuff because I think we should just avoid it for confusion's sake right now. So in our epic game folder, we're going to make a new file in here. Let's call it main.py, all right? Main.py. What is main.py? Again, main is a legacy thing that's just used for in Python to let people know this is where your game starts, all right? This is the main logic for your game. So we're not going to add anything in here. Let's make a new file in here, and let's call this our classes, all right? Let's call this our classes. So in our classes folder here, a brand new classes folder, let's go back to our file here, where we have our little game, and this NPC class. Let's copy all of it. I'm gonna even copy the little comments and instructions at the top here and paste it in the classes Python file. This will only contain the class, right? And then let's go back to the classes, and we got our logic here for our game. Let's copy that and paste it into the main.py. All right, paste in the main.py. And then let's get rid of all those other files. No, so this classes file we put inside this Epic Game folder. So make a new folder, and we're gonna modify this game inside of this folder. So you can see the original classes on mine is right here, and we have a folder right here, and inside this folder we have a brand new classes file. All right. Easy to play, hard to figure out how it all functions behind the scenes and how it's written to function when playing. Yeah, so a fun pastime for a lot of programmers, and it's really, really great for beginners, like very, very good, is reverse engineering. Sounds fancy, right? Well, it can get very, very fancy and technical real quick, but reverse engineering is very simple. You've probably done it many times in your life already. It's looking at something, analyzing it, and then trying to recreate it, right? Trying to recreate it. We've technically already did that with our like our Hangman game and the singing game that we did. We looked at something that's already existed. Hangman's been around for a long time, and we remade it after analyzing the game. Same thing with Pokemon. You can look at Pokemon, analyze it, and then remake it. People do it all the time, all right? And it's technically easier to do stuff that way than from your original thought or idea, because you don't have to think about how to do things. It's already there, the balancing is already there, the stats are already there. You just have to literally like copy it. So, let's see here. All right. So hopefully that was enough time for you guys to make these two files and copy and paste all of the stuff over to it. All right. So if we try to run our main.py right now, you will see we get a awesome error. It says NPC is not defined. But why? We defined it in here. Great question. It's because these files are not linked to each other in any shape or form. Right? They're not linked to each other at all. We have to link them together. We can go about linking together by saying import and then classes. And if we rerun this, it will still get an error. But trust me, this is the first step. It's that easy. So import will work on several different levels. By default, import will first look in your local directory. All right, it's going to look in your local directory and see if you have any files with this name. If you have files with this name, it will then import it. If you don't have files with this name, then it's going to look in several other locations. We'll go over that later, all right? Just know it needs to be the same name as this file, just without the .py. Now, you'll notice that we're still getting this error. Why? Why are we still getting this error? We're importing classes. Well, when you import things, by default, they're going to come in a kind of like wrapped state, quote unquote. What do I mean by a wrapped up state? I mean, it's going to kind of be an object. It's going to be an object, effectively. Everything's going to be stored in a name called classes. Why? Because that's what the file's name was called. So if we do classes and then dot, you'll see that all of our stuff comes up. So pretty much we're importing this file, and this file is going to be all wrapped up and saved inside of the name of the file here, what we're importing. It's effectively a class itself, and we can access the items in there by doing dot, and then there's our NPC. So technically, if we, in this current state, if we want our code to work, we would have to change all our NPCs here to classes.npc. All right? And if we rerun this, you'll see it actually works. All right, let me run this again. It's actually working now. Again, we're importing the classes file in here. When we do that, it's effectively going to be wrapped up in a new variable called classes, and it's all done automatically on this line right here, this import line. To access any of the items in classes, we have to treat it like an object. We got to do a dot, and then we can access the items inside of it. Now, this might not be ideal for you because no one wants to go through and modify all of their code to add like classes, dot, classes, dot, classes. It's a lot of work. All right, it's a lot of work, and we're lazy programmers, so we don't want to do work. So there are other ways you can go about doing this so you don't have to make these modifications. So let's talk about a couple of them. There's this keyword called from. All right, there's a special keyword called from. Now, what this from does is it will allow us to import specific things from within a file. So instead of keeping everything in a file wrapped up in this special little variable here, we can instead just ignore that, get rid of it, say we don't want this, we just want to directly get the things that are in here, all right, like NPC. We can say from, and then what we want to get, we want to get NPC out of the classes file. So we're going to say from NPC, or am I getting this wrong? Is it, sorry, I think it's from classes import NPC. Yeah, there we go, sorry. So from this file, we want to directly get the NPC class, all right? So now we can run this and see we didn't have to modify our code now, all right? We didn't have to modify our code. We avoided all of our problems there, all right? Any questions on that before we move forward? Any questions? All right, if you got an error, Kamal, go ahead and put it in the 100 Days of Rootkit chat. Also, drop something in the chat if you are all caught up typing-wise, or if you're still typing. All right, let us know. Cannot import NPC from classes. Import name NPC. I would say first, is your line, does your line look exactly like mine? And then second, do you have that classes file? Do you have that classes file in the same folder? Also, I think hold on one second. CD Epic Game. Okay, there we go. So, also, if you guys haven't already, please CD into the directory, because I kind of, you guys are going to get messed up if you're not CD'd in the directory, because technically, again, imports are relative paths. So I was in a different folder. So when I was importing classes, it was actually importing the old classes version. I think it was. I'm not sure. So to avoid any type of issue, just CD into the Epic Game folder. So that way we can get the correct classes. So if you're having issues still, just put a period in front of classes like this and rerun it and see if that works for you. I think you can, yeah, you can, I think you can only do that for the from one. Attempted import, relative import with no parent package. Never mind, don't do that. Don't do that. We're missing a file, but I don't want to go through that. This should work for you if you're CD'd in the right spot. All right, if you're in the folder and you have your double check the spelling and make sure your line looks exactly the same here. When you post these errors, I need you to post more info because you're not posting the whole error, so it's making it kind of hard to figure out what exactly is going wrong. Just to make sure I understand, from is pulling from that specific file from the folder I am in, as well as the import. Yes. Okay, to also step away from, okay, let's just fix any further confusion that might be happening in our games. This classes file that we made, let's rename this to classy. Let's rename it to classy, all right? So it's a completely different name. So we can avoid any potential issues we're gonna run into. Let's see here. You're not in the right folder. Come on. You need a CD into the Epic Games folder. That should fix your issue. So make sure when you guys are getting errors, you're reading everything from top down so you can see exactly what's going on. And look at the location you are in and what you're trying to run. So you can see what potentially might be an issue. All right. So let's move on, shall we? So I'm going to comment out import here because we don't need to import twice. Now, this is really useful. All right, really useful because it's avoiding us, because remember, when we import code, we're importing a bunch of extra stuff into our game. We're adding more code, we're adding more load, it takes up more memory, it becomes heftier, all right, it becomes heftier. Now, again, relative, our game is very, very small, so it doesn't really matter. But for larger projects, it will matter. So this can help you keep your load smaller. Additionally, there are other ways you can go about importing stuff. So you can do an import where it's all wrapped up, all right? You can also do an import like this where you can get a single item. You can also do it for getting multiple items. So let's make, inside of our classy here, let's make another item. Let's make just a function by itself called my test. Right, this is just a function outside of the class, and we'll just say print hi. All right, so now we have two things in here we could potentially import. We have NPC and we have my test. When we import like this from classy import NPC, you're gonna see that it works just fine. But if we try to do my test, it's going to error out because my test isn't being imported, all right? It's not being imported. So to import multiple items on this line, you can put a comma and then say what additional items you want. So we can also import my test. So now we have my test, and if I rerun this, you'll see we get hi on the command line here. Hi on the terminal. Sweet. Now, this may get a little annoying. It's ideal if you stay as specific as possible, but let's say you need like pretty much everything in a file, and let's say it had like 100 different items. You may not want to sit there and do item, comma, item, comma, item, comma, item. All right. But you also don't want to just import classy where everything is imported and wrapped up and then have to add classy at the front of everything. So there's an alternative you can do. You can do asterisks, all right? You can do asterisks. Asterisks will import everything, right? It will import everything. So if we rerun this, you'll see everything works for us right now because everything gets imported automatically. So that is very, very convenient. Now be careful when you use the everything marker here, right? Be careful with that because you could potentially overwrite important stuff. So this is something I don't think we've talked about yet in Python, so I guess we'll go ahead and cover it right now. All variables in Python are up for grabs. What do I mean by that? Print itself is a variable that is holding the print function, right? That's holding the print function. I can easily change that to just a string. Now when I rerun this, you'll see that print now equals ASDF, and these no longer work, and it throws an error because it's like, what do you mean? Print is a string. So be very careful of what you're doing, your variable names, and what you're importing, because you could overwrite your own stuff, right? You could overwrite your own stuff. You could potentially accidentally call something another name that's already being used, etc., etc. That is why some people will just do the import only, because if you are using a duplicate name, so let me show this in another sense. Let's say in Classy, we have our own custom print function, and it instead just returns 1, right? Just something completely different than what the normal print function does. When we import asterisks like this and run, you'll see that we're going to get an error. We're going to get an error because this print function no longer works. We're overwriting it, right? We're overwriting it. So some people prefer never using from unless they know it's going to be 100% safe. Instead, they will prefer using import, even though there's some extra steps. They know that they're going to be safe because everything is going to be wrapped up in this name right here. So if I run this program right now, it's going to error out. So let me do classy dot, copy this, classy dot, classy dot. All right. If I run this program now, you'll see it works just fine. Let me rerun this. It works just fine. This print works just fine. If I ever wanted to use my custom print, I can still. I just have to put classy dot in front of it. And then I can use that custom print we made over here. All right. Let's see, there's, I think, some questions. Oh God, Slick's in here. Python doesn't care if it's built in. You can own it yourself. Exactly. Exactly. If it does, Python doesn't care. Everything is treated like a variable at all times, and you can overwrite anything. You can overwrite anything. Any other questions before we chug along here? So me personally, I'll do both. It depends. Or I guess there's one more thing we should show off here. I'll do both. It just depends. It just depends on whether I know something is safe. For example, if I'm importing something, I'll only do an import asterisk if I made that thing myself and I know that I'm not going to accidentally overwrite something. If I didn't make it myself, I'll usually import every single item if I'm going to use from by hand right here. I'll type in every single item I want. That way it's safe and I know I'm good. Else, I'll just do import right here and I'll use the dot operation in order to see, you know, what's attached to it and get to those items underneath. Oh boy. Oh man, Slick came in. Yo! With that $100 donation. You come here just to see that? You dirty dog, you. Get out of here. Get out of here. Chicken fight. Yeah, you missed the chicken fights earlier. We had some cockfighting going on live on the stream. My God. Thanks so much for that donation, Slick. My needs have been quenched. Yeah, are you satisfied now? You get some pleasure from that? You sick man. Said, yeah, I'm stuck, lol. It won't let me CD into Epic Game. Do an L. Yeah, it says Epic Game there. Are you doing a capital E for your Epic Game? What is that emoji, Kwai? My God, what is? You guys got some weird emojis. What is that thing? Yeah, Kamal, I would just make sure you're spelling the folder correct. Make sure you're using tab. Tab will always give you the correct names for everything. Oh my gosh, more of those weird emojis. All right, so let's look here. Importing. So one last thing. All right. Let's say this name classy. We were already using it, let's say here as a variable. Let's say classy equals I'm so classy. All right. Let's say we were already using this already. And we don't want to overwrite our import here. We don't want to erase everything we're importing. Are we in a dilemma? How do we ever solve this? Well, there's an answer. There's a special keyword called as, and it lets you rename things. All right, it lets us rename this import from classy to something else. What do we want it to be? We can say not classy. All right, we can name it whatever we want. It's just a normal variable. All right, so now everything is going to be not classy. So if I run this, you'll see we get an error because our NPCs that are being made are no longer, classy no longer works because classy is this string. Instead, we can use not classy. If we run it, it works just fine. All right, so you can rename the import. The original import name needs to be the OG correct name. As is a way for you to rename it to something else. All right. Very, very important for you guys to know. It's used kind of commonly, not like super common, but uncommon. It's uncommon, so it's not like rare, but it's not common either. Additionally, I believe you can do the same thing here. So if we had NPC, we could rename NPC to KFC, right? We can rename NPC to KFC. And as you can see, NPC no longer works. And if we change it to KFC and rerun, it works just fine. So as isn't just for the import, but we can rename these individual items. And you would still use commas like normal. So we could do comma and say like print, all right? So within the same comma, you would do your renaming, but you can still import multiple things afterwards, all right? So some extra keywords for you guys to know there. Import, from, and as. Any questions in regards to that before we chug on forward here? Kamal, did you figure your stuff out? Ghost Cheeks for the huge donation. Look at that, we're about to hit 1K. With the matching at the end of the month, we'll be at a K. All right. So, moving forward, let's squeeze in one more thing before we let's see. In the process, a break would be great. All right, we'll go on break here in just a second. I'm gonna squeeze in one more thing. So, should I? No, we're just gonna do a break early because this next thing is gonna be a big concept. All right, so we're gonna take a little bit of an early break. We'll be back in 3 to 5 minutes. All right. If you have any questions, put them in the chat, or you can put them in the Discord chat. All right, and we'll answer them right when we get back. All right. All right. I'll see you guys in 3 to 5 minutes. Alrighty. Let's get back to it, y'all. Alright. Is this... There we go. I feel like the music wasn't really trying... I turned it down so much it didn't really even turn down. Alright. Let's get back into this, because we got some things we gotta cover today, alright? Before doing that, if you guys didn't know, we are Rootkit, non-profit here in the US of A. We do a lot of stuff for free, like our 100 Days of Rootkit stream going on right now. You guys are here. Unless you're watching afterwards on YouTube. Hello, people on YouTube. You're missing out on the fun. Alright? On top of all this free stuff we're doing, we are doing our free giveaway. Completely free. All you have to do is go to our site, go to the blog, and then click on the Week 7 giveaway, where you can enter to win something. One of our merch items. I don't know what. Mystery. We'll figure it out on Sunday. Additionally, it's free to enter. You just have to subscribe to our YouTube channel, follow our Twitch, just basic free things. Alright? Also, if you like what we're doing here and you want to donate some moolah, we just had a donation come through from Slicky Boy. Alrighty. You can donate on here, and when you donate, you can redeem some epic merch from us, like our stickers, our super cool collab t-shirt, and the super epic sweater. Look at this thing. Alright, you got the Rootkit logo on the back and everything, alright? It is heavy duty too. Alright, this ain't some thin sweater. This is a thick sweater, and you got, of course, your little pouch right here, alright? All donations are being matched 1-for-1 for the first 10,000 donations. Those come through at the end of the month. We have pillar items that we're hitting along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one we don't need to get to, shaving my beard. No one wants to see that. So let's go ahead and continue and jump back into our code. So there's some concepts in object-oriented programming we have to actually hit on. So if we go to our site and we go over certs, by the way, the site is changing this weekend, so things may not be in the same place as they are right now if you're watching this at a later date. If we go to view requirements on our comp sci cert, in programming fundamentals, all right, programming fundamentals, if we click on it, there's our object-oriented section, all right, object-oriented section. And we got some terms here: encapsulation, inheritance, and polymorphism. They sound very, very fancy, all right? They're not, all right? They're very, very easy. They're nothing special. I mean, they are special, but they're nothing crazy. They just make you sound really smart, right? They make you sound really smart. I think we'll go over inheritance first. So, if we Google Python inheritance, we'll get a bunch of examples here, right? We'll get a bunch of examples. And look at that, W3 is at the top. Let's go check out what they have here for us. So, inheritance allows us to define a class that inherits all the methods and properties from another class. So remember the examples I was kind of talking about yesterday. One of the last examples I gave was, in a way, kind of going over inheritance. That was, if I have this phone and I snap it in half and then make it into a little tiny tent for my little ant people to walk inside of, I've just changed this phone, which is a phone, into a little tent. It is still a phone. It might be broken, but it's still a phone. But now it is also a tent. It has added features to it. That's basically this inheritance concept. It's taken straight up from biology. All right. So you have parents, right? You do. All right. You wouldn't be here right now if you didn't, unless you're a lab child. Are you from the lab? You're an alien? You don't need to go that far, buddy. All right. All right. So it's taken straight up from biology. So in biology, there's these concepts of like orders, and I'm not a biologist, so if I get some of this wrong, oh well. There's the concept of like orders and genies, and etc. etc. So basically, like, things can be a fish, for example. And underneath that fish category, they could be potentially a lot of different things. They're all types of fish, but they're not like, they don't have to be directly related to each other. Same thing with, let's go back to like video games. Goblins, all right? If you have a video game, there may be goblins in general. And there may be different types of goblins, like specific different types of goblins, like, I don't know any terms for different types of goblins, but maybe there's like, and I don't mean by like one's just slightly varying in height. I mean like they're all goblins, but they're like completely different ones. I guess elves would be a better example because there's like elves, and then there's like wood elves and high elves and whatever. There's like different types of elves, but they are distinct. They are distinct different classes of people. All right. Yeah. So does that make sense so far? So it's kind of the same concept here in Python with objects. All right. So we can have, for example, a class. What is a class? It's a blueprint. A blueprint for something called a person. What is a person? Well, this is a person. A person is going to be something that has a first name and a last name. And then that person can also say their name, right? Using this print name function, right? So when you make a brand new person, you can give them a first name, a last name, and you can have them say their name, aka print their name. Makes sense, right? This is what we've seen so far. You know, making a new class, defining it, and then generating an object from it. You can use this class to make new classes through inheritance. So for example, if we wanted to create a child, because a child is a person, right? Right? Really? God, you think that low? I have children. How could you say that? Children are people, all right? Believe it or not. So you can perform something called inheritance. How do you do inheritance? Well, remember that we showed how, let's go to our classes here, how we can have parameters that we pass through our NPCs, like total HP. Total HP equals 50. So we just modified the total HP for this NPC. But this is directly linked to our special init function here, all right? Special init function. We're never putting anything in here, except we can. It's just not going to be this. What you can put inside of these parentheses here is other objects you want to inherit from. So for example, you can see here, our new student class is inheriting from person. What does that mean? What does it mean by inheriting? Ultimate copy and paste. All right. I told you guys, stealing, copying, pasting, it's quintessential for programming. Laziness, Genius ID. Pillarstone t-shirt, and all the little pillar stones are going to be copy, paste, steal, lazy, developer. Oh man, genius ideas. It is literally a built-in copy and paste. You will copy everything in person and paste it in student. So at this state right here, I don't think we've talked about pass. What it means is don't do anything. I just exist, right? So this right now is basically an exact duplication, exact clone of the person blueprint. All right, the person class in this current state. The cool thing about inheritance is you can build upon it. So right here in their next example, they're just showing that everything that was in the person blueprint has been successfully copied over to the student blueprint, and it's usable. The great thing about this though is we can add new functionality. I'm just going to scroll down. We can add new functionality to this student class that wasn't originally in the person class, but also copy everything that was in the person's class. So you're basically, it's a smart, like, hidden way of copying, pasting the code, and then adding your new custom logic to it. All right, your new custom logic to it. So what do I mean by that? Let's see some examples of it, shall we? Let's do some modifications to our code here. Any questions before I move forward, I should ask? Awesome, Kamal, you fixed your stuff? Perfect. All right, so, for example, we have our NPC. Our NPC has been working just fine for us, right? Just fine for us. But there's a general rule of thumb for programming, especially with object-oriented programming. You should never try to make what's called a God class, all right? A God class. What is a God class? It's a class that is used for everything. So we've kind of made this into a God class, essentially. What do I mean by that? Well, we don't really want to use the same blueprint for shopkeeper NPCs who may never fight. So they don't need this logic. And then also for like goblins or bosses, we don't want to use that same exact class on all of them, because there's going to be various levels of complexity to each of them. And then, like I said before, some NPCs, like shopkeepers and stuff, we may not want them to be able to battle or fight. Maybe you do, maybe you don't. But when you are doing that, you're effectively bulking up your code, because now you have this logic that's attached to your NPCs that you're generating that you may never end up using on them. So you're effectively making your game bigger, less efficient. It's going to take up more RAM. Your users are going to complain because your game runs on their high-end computer, like, and makes it into a toaster. So that's not great. So there's this concept of abstraction. All right. If you are good at math at school, this should be a little easier for you. It has nothing to do with math. It's just the concept of abstraction. If you find yourself being a very analytical person, someone that performs analysis or is able to analyze things well, this may be something that's more easy for you to understand. If you're neither of those, then just practice and it will come along easily. All right. So there's this concept of abstraction. What do I mean by that? It's good to take an idea and extract it out into its more like core components. So, for example, NPC. Hold on, I'm gonna take out this gum in my mouth. The NPC is a potentially abstracted class, because technically all people in our game may need. If they all need something, we may want to put it in an abstracted class like NPC, which will deliver base stats, base items. What do I mean by that? Well, let's start with a clean slate here on our NPC. If this is going to be used for every single NPC, it should be as small as possible in just the base things that all NPCs should have. Yeah, Slick called me out for not being able to speak right. Yeah, sorry, the gum was like going all sorts of weird places. Something they might all have, maybe a name, all right? Maybe they all have a first name. Maybe they all have a last name. Even if they're a goblin, we don't have to fill in last name particularly. We could just put in first name. I'm putting these as empty strings right now. We'll deal with that here in a second. They could also have things like, I don't know, maybe they all have health. So we're going to say all their health by default will be, I don't know, 100. All right. Almost spilt my drink. And maybe they can all do stuff like say their name. So we'll say def, say name, self, and by saying name, you're just going to string. We're going to say your first name and your last name dot format self dot first name self dot last name. So nothing special here, just a method that's going to do a print, and it's going to print out their first name and their last name together, right? And that's about it, right? Because shopkeepers and stuff may not really have the concept of defense or a bunch of complex stats like that. Maybe they do, maybe they don't. All right, we're just going to roll forward with this for now so we can get the point across. So let's say from our NPC stuff, we're good. We think that all our NPCs will have these base items. So from here, we can make new classes. Let's say specifically we want a class for our player. So when we're making players, we'll have a class for players. So again, pass is like, hey, Python, I'm going to come back later and program what this is out. But right now, just don't worry about it. That's what pass effectively does. If you don't have pass here and we want to keep programming like making another class, it's going to yell at us and cause errors. So you put pass in here to be like, hey, I'm putting a pin in that. I'll come back. All right. So let's say we also want to make mobs. All right. Let's say this is for our goblin race. All right. Goblins. Now, our player and our goblin are going to have their own name. They may not have a last name, but they're going to have a name. They may have health, and maybe they want to say their name. All right, maybe they want to say their name. So these are all useful items we may want to have a part of these classes. So we can do something called inheritance. We can inherit what is inside of NPC. So we can effectively copy and paste this code right here that I have highlighted inside of both of these. And how we go about that is we copy the name of another class, all right, another blueprint we want to copy, and we paste it inside of these parentheses, all right? We paste it inside these parentheses. Now we are successfully copying everything from inside of NPC and putting it inside of player here. All right. This allows us to then do some custom logic for player and goblins. All right. That are inside both of them. And you can go as many realms down in this you want. What do I mean by that? You could have, let's say, NPC and then another class called fightable NPCs. I don't know. I'm just making up. This might not be the best thing to do for your game. I'm just making up some stuff right now. Effectively, let's say in our fightable NPC, this is what will define basically what every fightable NPC would have, aka some of those stats like our attack and our defense, right? Our attack and our defense. And say the default attack is 5 and the default defense is 5. So anything that can that's an NPC that could potentially fight would be a part of the fightable NPCs. We also need this thing called super. We'll talk about what that is. It's super underwhelming. All right. Now we can copy this fightable NPC because our player and goblins can both fight, and we can put that into here. This is what I mean by it can go pretty much infinitely in the Inception matrix. You can have things that inherit things that inherit other things that inherit other things. We can have a base NPC class, aka our base NPC blueprints. This will be everything every NPC ever in our game will ever have. It's very small and lightweight to ensure that it's not adding extra bloat to our game. We can have things like fightable NPC. So this will be for everything that's potentially fightable. We could have another class for non-fightable NPC. All right. And this would be stuff like, I don't know, let's say, they have a store, times their store are open. So open times for their store. Let's say their store opens at 10:00 hours and then their closing time is at 20 hours. So all non-fightable NPCs, which let's say shopkeepers, would be then, they would need to know when they open up shop and when they close shop, because we have daytime, I guess, in our game here, our made up game. All right. So this is kind of showing the illustrating the point here. Don't worry about super. We'll get into that in a second. But this is kind of showing off the point of all NPCs are going to be inheriting this NPC class. And then we can use that to then funnel into other concepts which add more stuff, which then funnel into other concepts which add more stuff. All right. So this is inheritance. Any questions about this so far? So I guess we should maybe see some functional code here. So let's make a player. All right, let's make a player. I'm going to clear this up. We don't want to import NPC anymore. We want to import player. So if we want to make a player, I'm going to call this player Elijah. All right. And we make a player based off a blueprint. All right. Our player blueprint is called player. All right. That's that thing all the way down here. When we make this guy and we do Elijah dot, you're going to see here that he has pre-built into him this concept of attack and defense and first name and health and last name and say name. Why does he have all this? Because he is an NPC. And he is also a fightable NPC because we're inheriting from fightable NPC. And fightable NPC has these items in it, but also it's inheriting everything inside of NPC, which is made in here. Are there jobs that consist of proofreading through codes of line, like fixing errors in... No. Kind of. If you're like a testing dev, but no, that's why you do peer review before you launch your code. So your peers can see it. Also, there is auto spelling stuff. I just don't have it on right now. Why? Am I misspelling everything right now? Is it that bad? Question. So how would you write them into the player's code? Hopefully I kind of showed that off here. We're gonna go over how we can add stuff to player specific in just a second. But I just want to show off like exactly this inheritance thing and how it works and how it can be very useful. The big useful thing in here is abstraction. It is the concept I'm saying right now that's very, very important. Because anyone can be like, I want to make a game, and so I'm just going to make a player class. And that player class, you could, make first name, last name, health, attack, defense, etc. Let me show it here. So these aren't inheriting from anything anymore. You could, and this is pretty normal for like beginner devs, they'll make a player class and they'll add all these items to the player. And then they'll make a goblin class. And then they'll add all of these items to the goblin class. Whoops, I need to get this. And then they'll say, oh, I don't need a last name, because they'll just have a single like name. All right. The thing is, this is not dry. Remember, we want to be lazy devs. All right, we want to be lazy devs. We want our code as dry as possible, so we don't have to change things in multiple different places. Additionally, if you are kind of retarded like me, and you don't know how to spell, you can't speak things correctly at times, if I mess up or spell something here differently, like defense, all right, and we have defense here, then you have different naming schemes, which may mess you up later on. So, for example, if we made a player and we wanted to see the player's defense, it's called this. But if you wanted to, let's go ahead and get, what do we call it? A goblin? Let's go ahead and make a goblin. I'm just going to call it that. And you want to get the goblin's defense, and you named it this, they have different names. And if you wanted to go through and correct the names or change the names to everything, you would have to then go through and change everything, and it's going to be a lot of work. Or if you set it up properly like this, it would all be in one place. It would all be defined in one place. If you want to change defense to something else like def like this, immediately everything in your game is automatically going to be changed from to this because it's inheriting. So again, the trick is keep your stuff dry. Be lazy. I want you guys to be lazy, all right? I want you guys to make good code that allows you to put in less work and less effort. Let's see. I can see the question. It wasn't entirely just curious if there are jobs, 100 lines. Yes and no. It's more and more being done automatically through automation techniques and testing frameworks, which we'll go through. I don't know if we'll get to that stuff. It's not required for our cert right now because testing is important. It's going to be done in pretty much every job that you... I shouldn't say that. There's lots of jobs that don't implement testing techniques at all, but they'll usually teach you on the job how to do that. It's pretty straightforward. Sorry, can you go over what pass means? Pass means, hey, I'm putting a pin in this. It's just you telling the Python programming language, like, hey, buddy, I know I made this thing. I don't know what I'm going to do with it just yet, so just ignore. It's the equivalent of me doing this. It's the equivalent of me adding nothing to player. The thing is, you can't add nothing to a class because it's going to start airing out. Like you see right here, it's airing out. So they have this thing called pass, which just literally does absolutely nothing. It's just there so it doesn't cause an error when you have nothing inside the class. Yeah, I think I already answered this for you, Kwai, but yeah, there's a lot of automation stuff. I don't understand. You're probably just overthinking it. It's literally means nothing. It literally means like I made something because look, for example, if I make player in Goblin like this and I click play, it's going to be mad at me because there's an indentation block after it. It's going to throw some weird errors. It's mad because I didn't put anything underneath them. So to make it not mad at me, I can use this special thing called pass, which is basically saying, hey, don't yell at me anymore. I'm going to program the rest of this out later. And now it works. Let's see what Google says specifically for it. Python pass. Create a placeholder for future code. That's literally it. It's a placeholder for future code. It's literally saying, hey, I'm going to put code in here eventually, but I'm not putting any code in there right now. All right. So, let's go ahead and fix our inheritance here. So inheritance, super awesome thing. All right, super awesome thing. You guys need to know it. You need to demonstrate it for the exam. And it's going to come in very, very clutch for you. All right, let's see here. Let's go over. Actually, no, we got to talk about super. What is super? Is it super complex? Am I going to get super annoyed at it? Am I going to get super cancer from it? The answer is no. It's very super underwhelming, all right? What super is, it's a special word. As you can see, we never define super anywhere. So it's a special built-in Python word that means, hey, I see that you are inheriting from this NPC class. Do you want to do anything with the built-in functions inside of that NPC class? So for example, if we do super dot, we'll actually say anything in here. If I do dot same name, no. It's just a special keyword that lets you run others. Hold on one second. I want to see real quick online dot. Let's go to the docs and see if they can explain it a little bit better. Give us an example here real quick. So super is going to be, I don't really like the term super. Other people call it, in other languages we'll call it something like parent, or what do they call it in Java? I'm forgetting right now. I'm not the biggest fan of super, but it basically means what the class above you, the class that you inherited from. You can access items from inside here. So for example, if we look at this code example, so forget this bottom part, look at this top part first. We have a class called animal. Object is another special keyword that's technically like, that's the default thing that you're given in Python. That's when we do empty parentheses, it technically always has this object thing. So you're always inheriting from a base thing called object. So don't worry too much about this. Let's look at this right here. We're making a blueprint, all right, for an animal. When you make an animal here, it wants you to give it an animal type, right? It wants you to give it an animal type, and then it's going to print the animal type out. By default, when you inherit something, it's not going to run this init, right? It's not going to run this init. So from the parent class, right? From the parent class, from the one you're inheriting from animal. So in order to run that init, you have to use super. That this is a special thing for running this, and then you can run init. Let's go through let's make this in our code and give show an example of it. So let's say right here, we're going to print hello. All right. So NPC is going to print hello when we make an NPC object. Player is an NPC object, right? Because we're inheriting from NPC, which is then creating the fightable NPC, which we're inheriting from right here. So if we make our player right here and we run this, we should see when we create our player, we should see hello get printed out, but we do not. Is this, yeah, it's still showing up, but we do not. All right, we do not. So what's happening here? Technically, a init is not being ran from this. All right, a init's not being ran from this. So in order to get a init to run, we have to use super, and super only goes up 1. All right. So in fightable, I'm going to take away non-fightable NPC here. So we're not using it right now. So there's a special built-in keyword called super. All right, and you can use super to access. See right here when I do super, and then it's a function, and then I can do dot. I can access everything that was in the parent class. All right, one class above us. So in here, if I say underscore underscore init underscore and then run init, now it's running this init, so I should see the hello get printed out. So let's run this, and you can see now hello is getting printed out. All right. So super is a super underwhelming thing that will execute anything on the parent class, right? Automatically. What questions do you guys have? I didn't see, okay, my bad on the YouTube people. Again, YouTube always has it for top chat, for the chat thing by default for me. So I just changed it to live chat, and I saw second channel you were posting some stuff. I totally missed it because of good old YouTube. So sorry about that. Let's see here. The semi-simple things get super time consuming. Hopefully this isn't too confusing. It's just a way to access the parent class. That's the super simple summary for it. It's a way to access the parent class. Why do you need to do this? Great question. You can overwrite things from the parent class. What do I mean by that? What do I mean by that? This is why you have to run super.init. You are technically overwriting and replacing a init because you have a init here and a init here. So you're technically overwriting it with a brand new init. That is why you have to run super.init here in order to get everything from this. So for example, if I say inside of the fightable NPC, we have something called say name here. So let me go ahead and do Elijah.sayName. And technically this is going to print nothing because we have no default name here. So I'm just going to say default name. All right. So when Elijah says name, it's going to say default name. If we run this, you're going to see it says default name there. Let me run it again so it's a little bit more clear. It's going to say default name here. All right. We can overwrite say name here in one of these child classes. So if we don't like what the parents' functionality was, we don't like what our parents did, we can be better than our parents. All right. We can say def say name. And I don't want to do super. We can say print I'm not my parent. There we go. So we are now overwriting the previous version with a new version. So if we run, you'll see that it says I'm not my parent now. All right, it says I'm not my parent. We've totally lost all functionality from the original version of it. All right, from the original version of it. So this is an option you have. But let's say you liked the functionality of the original version. You just wanted to do more stuff with it. All right, that's where super comes in super handy. All right, we can say things like super dot say name. This will execute the previous say name function and the rest of our code here. So if we save and run this, we can see that it says default name, I'm not my parent. So now we've not just remade the say name, but we're building upon it. We're using the previous logic and we're making brand new logic. All right. If that didn't make sense to you, don't worry. I'm gonna show a video game way of it. All right. Let's get back a little bit into video game territory and why super is awesome, and why you need to include super in your init here in order for you to potentially inherit everything correctly. So let's say a fightable NPC is able to fight. So they should be able to attack, right? So self, and their attack will do some calculations here, right? It will do some calculations. It's going to return, let's say, self dot attack plus, I don't know, plus let's do our health scaling thing again, right? Just to make it a little bit more complex. 21, all right? Also, they can take damage, right? And when they take damage, we're going to take their health. Self.health is going to minus equals we need to know what the damage is. Damage. All right. So now we have a way. So in our fightable NPCs, they can attack and they can take damage. Cool. Awesome. Now all of our players and all of our goblins can do the same thing because they're inheriting from fightable NPC. Let's say this attack logic makes sense for most things, but in our player, we want to add some extra complexity. All right. Let's say in our player, all right, let's do def init in our player. And let's say our player can hold something like a weapon. So let's say like weapon name. And then also that weapon has some stats. So let's say like weapon stats. And let's say weapon, I guess, damage, right? Weapon damage. Let's say it's the weapon's damage is 5. All right. That's cool. The player now has a weapon. Guess what? When he attacks, doesn't matter. We don't have any logic being used to dictate the attack. All right. It's not adding this to it at all. But we also like the default damage calculation. We just want to modify it with our weapon damage. This is where super comes in super handy. If we do a def attack, we are overriding by default the previous attack method with a brand new attack. All right. We want to add our, I'm going to remove this. We want to add our weapon damage to our attack. So we could say return self.weapon damage. There's an issue here because now we're only returning the weapon damage itself. We're not incorporating our previous attack logic. We're not modifying it based off our fightable NPC. And we can see this right now. If we do player and we say print Elijah.attack and run this, you'll see he only does 5 damage. He only does 5 damage. And previously, let's go ahead and copy this take damage out. So we no longer, sorry, not take damage, attack. We're commenting out our custom attack logic here on player. So now we're just using the fightable NPC attack. If we run this, it will give us an error. Okay, it gives us an error because it says that our self.health doesn't exist. Why doesn't it exist? It has super right here. Health is right here. Self is right here. What the hell am I missing? We have our super right here, so it should have... Did I spell something wrong? Health times... Player object has no attribute health. Oh. That's because we aren't using... so even though we made health up here, remember it's inside of this init thing. So we can't inherit anything that's made in the inits from above until we run that super.init here. So we got to write super.init. Remember, init's a function, so you got to throw those parentheses at the end of it. So we're not even inheriting our base stuff from up above that's inside of init, all right, until we run this. Even though we're inheriting, it's kind of, we're overwriting that default behavior. So we have to run this init here. So if we play now, int's not callable. Are you kidding me? Elijah.attack. Attack. What are you going to... Oh, we overrode attack. We have a function. So again, be aware, Python, you can name your variables anything. You can name your functions everything. But technically everything, including functions, classes, objects, are all variables. So you can see here, I have self.attack 5, but this is also called attack. So I'm technically overwriting my attack with this attack. So it's getting all messed up. So we should probably change this one to like attack damage. And then have this. So we run this now. Please, for the love of God, work. There we go. Could you write an overall line for health? Yes. Let me finish up with this real quick. We ran into some issues. All right. 15 is our normal damage. Using the attack functionality here in Fightable NPC. When we do our special custom attack here in player, we're only returning the weapon damage, which means we're only returning 5. That's way less than our normal default damage, which means the goblins are going to outdamage us because they don't have a custom attack thing on the goblins. They're using the default Fightable NPC. To add that base functionality, our Fightable NPC logic, with our new weapons modifier, we can use super. We can say super dot attack, not attack damage, attack plus weapon damage. What's going on here? We're getting the parent, aka this class's attack function, and we're going to run it, and then whatever it gives us, which it's going to give us whatever this number ends up calculating into, it's going to give us that number, and then we're going to add that number to our weapon damage. So now we have a new attack value. So if we run play now, you'll see we're now at 20. We're now at 20. So this is why super can be very useful. One, it's kind of required when you're using a init, so you can get everything that was made above inside of your new class here. But also when you're modifying or renaming a function like attack, sorry, not renaming, remaking a function like attack, you can use the previous logic and then modify it with brand new logic. All right, let's see here what we got in chat, because we covered a good amount of stuff there. Could you write an overall line for health? What do you mean exactly for health? Can you explain that a little bit more, Kwai? Sorry. These were print games. So no, we're not going over any GUIs because GUIs are going to be a waste of time for when it comes to our comp sci degree or cert. But we definitely encourage you to mess with GUIs outside of it, but most of your time as a dev, you're not going to be messing with the GUIs at all. Any other questions so far? If you want to do proper game development, definitely get our cert, learn all this stuff, and then it's going to be very easy for you to pick up things like Unity and Unreal Engine. Those are where you're going to want to make games. You don't want to make like an actual 3D game in Python. All right, it's not going to run very well. It's going to be it's not going to be good. You have to use an engine and the languages in those engines, which is going to be C# for Unreal, and it's going to be C++ for Unreal and C# for Unity. Technically, in Unreal, you don't need to program in C# at all. C++ at all, because they have a node editor, which is basically like building blocks. You just drag and drop with each other. That was a question from earlier when you mentioned health was being overwritten. I was wondering if there was an overall health line, but I suppose that would get too complicated. Yeah, if I did that, my bad. The main concept I wanted to show off was attack, how you can modify attack, and why super is important, useful, and how you would go about using it. I'm just trying to really nail down the super point, right? Because it's super underwhelming, but it's also super important. Again, it's all because we're rewriting a function that was in something else, because we're remaking a new init here, and that's why we have to call the super, right? And we're making a new attack here that was made in the previous one, so we have to write a new super. If we had a function that wasn't previously made, like Bobby Joe, we don't need to run super in here because there is no previous super Bobby Joe. Now we can still run super in here. You can only run super on anything that was made previously. So maybe, I don't know, and for Bobby Joe for some reason, maybe you needed the attack damage. I don't know why, but maybe you needed it. So you would grab that. Attribute error. Player object has no attribute attack. Great question. So attribute errors mean that you tried to do the dot here and it couldn't find it. So you tried to do, for example, let's say I haven't made anything called Elijah.asdf. So if I run this, you'll see I get that same error. Player object has no attribute ASDF. So that means your attack doesn't exist in the player object, which is going to be based off the player class, the player blueprint. I'm assuming it's because you used a lowercase p when you tried to create an object, because that error has a lowercase p, and you should be using upper camel case for your class names. All right, so we're getting towards the end of our lesson today. So let's just do a big review here real quick. Today, we talked about importing. You can import things like you've seen normally. You can import files locally if they're right beside another file, all right, just by calling their name. If you want to, once you import a file, you can access it just like an object by saying that file's name and then a dot, and then access any of the code within it. You can also rename that file in your code to something else temporarily. So we're renaming classy to not classy by utilizing as. If you don't want to import an entire file and only certain items from a file, you can use from. All right, you can use from and then say which file and then import the individual items you want from that file. You can also use that as keyword again here to give things a brand new name if you want, and you can use it as many times as you want. So as hello, right? You can use it as many times as you want. It's still just comma separated afterwards, right? I'm gonna remove that. And then you also have the option of doing asterisks. If you want to do asterisks, just be careful. Asterisk does everything, so you might accidentally overwrite something, right? You might accidentally overwrite something. For classes, today we showed inheritance, and it's simple to do inheritance. You just take a class and then you put it inside of another class in the parentheses right here where you declare the class. And it's basically an auto copy and paste. It will automatically copy and paste everything from the previous class into your new class. When you make a new class, if you make a function, a function method with the same name of something from a previous class, you're going to overwrite it, which means all this logic from this previous class, this one right here, is no longer going to run, and you're no longer going to get first name, last name, or health, for example. Unless you use something called super. Super is a special super function which will let you access anything from the previously inherited class. It only goes up one. From in there, you can do, you can call the .init function, which will run this logic right here, so that way you get those items added. Right? So you get those items added to your new class, even though you overwrote the previous one. And that's pretty much it for the most part. Just remember, super only goes up one. It only goes up one. But you can technically chain them. Right? You can technically chain them. What do I mean by that? You can write, for example, let's do it right here. So if I say super here, it means the fightable NPC class. So I'm going to run init from the fightable NPC class. Technically, you can chain them together. So I could say super dot. Does that not work? How do I do that? There's a way to do that. There's a way to basically say, I want to go to my grandparents class. So if this is my parent class, fightable NPC is my parent class, NPC is my parent's class. There are ways to go all the way up to a higher version of the class. I guess I just forgot it right now. It's not super important. The only thing that's important is that you just know there's this thing called super. All right, it allows you to access stuff from previous from parent classes. That about wraps up what we talked about today. Now, what I want you guys to do, your challenge, I want you guys to make you can erase this file, comment this file, do whatever you want. I want you guys to make 2 new classes. What they are about, I don't know. I don't care. Maybe it's a car class and then like a car brand like Ford. All right. Maybe it's, I don't know, literally anything. I want one class to be the parent class, and I want you to inherit that class into the second class, the child class. All right. I want you to make 2 classes, one that will be inherited into the other one. And then I want you to print out all of the stats from the parent class and the child class just by using a print statement. So you might have a couple print statements based off of how many like properties you give to the parent and the child. All right? Just want you guys to do that. All right? You're just running through doing inheritance. It will also force you to utilize super. All right? So that's your challenge. Go ahead, do that. Any questions before we end the stream today? Any questions before we end the stream? Yep, go ahead and ask your question, Kamal. Yep. Did you fix the capitalization? If you're still getting that error? Because I'm pretty sure player is supposed to be capitalized. I put it in the Discord. Let me check. I don't think you put it in the Discord. Oh, I'll put it in the Discord. Okay, you're putting it right now. Yeah, remember Sunday, you guys. Yeah, remember Sunday is our chill Q&A, so we can talk, discuss more. Tomorrow we're going to talk about classes more, right? We're going to go over polymorphism and whatever the other one is that I can't remember right now. All right, we're going to go over both of those. We're going to conquer them, and then Sunday is just going to be chill Q&A. We're going to go over, most likely, I'm going to assume you guys are going to have more questions, and so we'll probably spend all of Sunday going over classes also. So we're spending lots of time going over classes and understanding them, right? So, okay, so from classy, import player, Elijah equals player, Elijah dot attack. All right. I'm just waiting for you to post the error. Also, you guys can use your own names here, right? You don't have to use my name. Yeah, so it has no attack attribute. So I'm going to assume that your attack here isn't defined. Because that's what it means, is it doesn't exist. You never made it before. So for everyone else, that's pretty much all I got for you guys. I'll see you guys tomorrow. All right, and we're gonna be going over more stuff about classes and objects. All right. And I'm gonna just stick around for 2 more seconds helping Kamal here real quick. Thanks you guys for attending. Is your fightable NPC there named correctly? Because it's a lowercase f. Oh, what's up, Taylor? Here, I'm gonna end the stream. Kamal, if you want, join the events chat and we can chat in here. You can share your screen if you want. All right, I'll see you guys on the next one.